people watching this video, we're going to go through the review. They chose to go through the review together. I said I might make you do a problem and then we'll go over the answer, whatever. But make sure that as we're going through this, you understand what's going on because test day is Friday. Tomorrow we'll probably do some whiteboards. Just because probability, like repetition with whiteboards is really, really good. So, all right, number one. You guys see this? This is like a two-way frequency table, even though it's not a table. We have flights that were on time, flights that were late, and then we have the two different airlines going across this way, right? Like there's two different things going on, yeah? All right, so the following table contains data from the study of two airlines. If one flight is selected, find the, what's P stand for? Probability of on time and upstate airlines. Okay, which one of those four numbers is on time and upstate? 43. So I put 43 out of
87.
Is there 87 total?
Yes.
Perfect, I believe you. 43 out of 87. That was not hard, correct?
That's it?
That is all.
I like probability, by the way.
We like probability. All right, number two. A firm uses trend projection and seasonal factors to simulate sales for a given time period. 0 is assigned to fall. 1 is assigned to steady. 2 is if the sales are rising moderately. 3 is if a sale is rising a lot. The simulator generates the following output. Estimate the probability that sales will rise at least moderately. Okay? Which one is moderately? 2. What else do I consider?
1 and 0. 16.
At least moderately means
3. 16.
2 or
3.
3, because at least moderately would be a 2 or 3. Moderately or a lot. So we're looking at any 2s or 3s. I see 1, 2, 3, 4. You count also. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I see 16 out of 31. Perfect. See, this is not hard. Okay? This is not hard. 16 out of 31. Happy with that? Jake comes in. 16. The answer is 16. All right, whatever. Okay, good? Yes? All right, we've got another frequency table here. We have a positive test result and then the disease and no disease, right? So a couple false. Real quick, who are my false positives? Which number is a false positive?
Positive that doesn't.
Which number?
11.
11 is my false positives.
False negative is 4.
Who are my false negatives? 4, okay? Those are my really, really lucky people and my really unlucky people. Or I guess they're both maybe unlucky. I don't know. Anyway, if one result is randomly selected, what is the probability that it is a false negative? Hey, we've already identified the false negatives.
4 out of
There are 4 false negatives out of
298.
298. Okay, and then they ask me another question. Be careful for the, double questions.
It's not good.
Okay,
if there's double
4
questions-
out of 298.
Oh, it's not
What
bad.
does this probability suggest about the accuracy of the test?
Isn't
Hey,
it 5%
If there's
thing?
double questions, can it count as 2 points? Yeah.
I mean, unless you get them both wrong and then you're double screwed.
No, I like probability.
Okay, sure. So 4 out of 298, what percentage is that? That's really low.
1.3.
What?
1.3.
1.3%?
Yes.
1.3%. Let me get rid of my dot here.
So yes,
Okay,
accurate.
so basically the test is 99 or 98.7% accurate.
So yes, it's accurate.
That's pretty good. Like you don't ever get a test that's 100% accurate, right? 98.7% accurate. That's okay.
Okay, not bad.
Not too bad. Not too bad. Not bad. Okay. Now, I would be more interested in asking you. I probably wouldn't ask the question, does this tell whether the test is accurate or not? This is what I would ask. I would say, what is happening to those 4 people that is bad?
They are getting no treatment for a disease they do have.
Yes, so they're going to die. What about the 11 people?
They're getting treated for a disease that they don't have.
Yeah, so they're going through all of the, maybe it's chemotherapy or whatever, and they don't actually have the disease, okay? So there are adverse side effects to each one. What is the best thing to do in this scenario? To eliminate false positives and false negatives.
Double test.
Test again, right? And then the chances of them double testing false would be very, very low. So we would catch those people who are getting false positives and false negatives. All right, flip a coin twice. Create a sample space. What's a sample space?
Heads, tails, heads.
Listing the outcomes, okay? I usually list them in like these little bracket things. So if I'm flipping a coin twice, I could get
Head,
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 tails.
tails.
Okay.
Tails, head.
tails, heads, tails, tails.
4.
There's 4 possible ones, okay? Now, I am not going to ask you to list them out, but what if we were flipping 3 coins and I made you list them out? How do you know how many outcomes there would be?
You take it times.
3 times. No.
2.
Is that 3 backwards?
2, there's 2 options for the first
Yeah,
coin,
So it's 6.
2 options for the second coin, 2 options for the third coin. So how many outcomes?
Oh, it's
8.
My bad.
If I flip 4 coins, how many is that? 4 coins. 2 times 2 times 2 times 2.
16.
There would be 16 in that space, okay? So if I ask you those things, you can make a list of them and you know how many you would need to have, right? So that you don't forget any, yes?
Okay.
Okay, good. Number 5.
Maya writes the 3 backwards and goes, is this 3 backwards? Does this look backwards? Like, yeah.
I have those days where I'm like, I can't spell correctly. It like looks like it's
a number.
spelled wrong, whatever.
You're not.
Number 5, we are simulating a hit or an out. 1 is a hit, a 0 is an out. I don't know if we're doing like batting practice or something, whatever. Anyway, hit versus out. Estimate the probability he gets a hit.
It's supposed to be progress.
Yeah.
Cut me.
Hits are 1.
20.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, out of.
And zeros are 22.
And there's 22 zeros, so 42 total. Yes, 20 out of 42. Let's reduce. Divide by 2 at least, I know. 10 out of 21. Anything else reduce?
That's 48%.
No.
That's 48%. Perfect. Sure. Okay? Good? In a certain class of students, I start listing 11 boys from Wilmette, 7 girls from Wilmette, 5 boys from Winnetka, and 4 girls from Winnetka. 4 boys from Glencoe, 4 girls from Glencoe. If the teacher calls upon a student, answers the question, what is the probability the student will be a boy? This is way too much information for me.
Disregard the towns.
Plus 5.
Okay? I put it in a table format so I make sure I don't get anything like wrong. So I have boys, I have girls.
20.
20.
Wilmette,
How many women are there?
20 plus
Winnetka,
27 plus 4. 27 plus 4 is 31. 31 plus 4 is 35.
11 boys,
7.
7 girls, 5 boys, 4
A
girls,
little under
4 boys,
half.
4 girls. So we're looking at just boys.
Right?
20
20.
boys.
20 out of,
35.
sure. 20 out of 35.
Is
Divide by 5
out of
is
7.
4/7. That should go up on number 6. Sorry, I wrote down
Oh, I
below.
wrote it on 7 because
Okay.
of you.
Sorry.
Oh.
It's fine. You still got room maybe a little bit. Okay?
What percent?
All right, I have to write it in a table because I don't trust myself to just add the right numbers together. So I have to write it out. Anyway, whatever you want to do, as long as you get it right, I don't care. Okay, number 7. I'll use a different color since I'm on the same thing here. Assume that a study of 500 randomly selected airplane routes showed that 482 arrived on time. Select the correct interpretation of the probability of an airplane arriving late.
18
Interpret an event
out of 500.
as significant if it is blah blah blah. Okay, so 482 out of 500 arrived on time.
Which
500.
When is this test going to be?
Friday.
Okay, I'll be
Okay, this is on time.
here.
So how many arrived late? 18 out of 500. That is what percent? 0.36% or 3.6%? 3.6%. Okay, so
Yes, accurate.
is it a significantly rare occurrence
Yes.
no.
for a
No.
plane to arrive late?
No, isn't it
No.
below 2?
No, period. I thought it's 5. Period.
Interpret an event as significant if its probability is less than or equal to 0.05. Now this is a percent, so this would be 0.036, which is in fact less than 0.05. So yes, it is significantly rare. It is significantly rare for an airplane to arrive late.
No.
So if they give me these stats ahead of time and I am on one of those planes that arrives late, I would be like, I am super unlucky, right? Because it is like very rare to be on a plane that arrives late, and here I am, right? Yeah. What?
That's such BS. Planes are late. Like
Planes are late way more than that. You're probably right.
It's
Yeah.
like 482 out of 500 are late.
Are late instead of on time. Whatever. All right, select the correct interpretation of the probability of getting 11 when a pair of dice is rolled. Interpret this. Ooh, I like this one. I like this one. Let's talk about our dice, but I need a bigger area. Can I erase this last problem? Okay, I'm going to erase this last problem because I need a table. Okay. When you're rolling 2 dice, I like to put, there was a table up here. Do you remember this on this board where I had like 2 dice? No, you don't remember. Okay. So it looks like this. And I could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6 for the first dice, right? A 1, a 2, a 3, a 4, a 5, a 6 for the second dice. So the pairs that I could roll are like 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 1, 2 and 2. You get it? 2 and 3, 2 and 4, 2 and 5, 2 and 6. How many different combinations are there of me rolling 2 dice? People say 12 all the time.
36.
36 total, right? There's 36 total combinations. How many of those combinations will give me a sum of 11? What are the combinations that will give me a sum of 11? 5 and 6
And 6 and 5.
and 6 and 5. Anything else? 7 and 4?
There's no 7.
No,
There's no 7, right?
That's 12.
Okay, anything else? Anything else?
No.
Those are 11s, right?
2 out of 36.
2 out of 36, which is what percent?
I don't have a calculator.
18. 1
Probably
out
about
of
1 out of
18.
18, which is
1 out of 18, which is
5.5%.
5.5%. Okay, so is it a significantly rare occurrence for me to roll a sum of
It's
11?
above 5.
No. What about a sum of 12?
Yes.
That's 1 out of 36. 1 out of 36 is going to be less than 5%. So it would be very rare for me to roll a sum of 12,
Yeah.
right? It's going to happen, but it's significantly rare. It's significantly low occurrence. Interpret the event as significant. It is significant. Yes, significant.
I thought it was not.
It's not.
No, it's not significant. Woo! Okay, I'm still thinking about 12. Not significant because 5.5 is greater. Good. Not significant. Okay. Number 9. A study conducted at a certain college shows 65% of the school's graduates find a job in their chosen field within a year after graduation. Find the probability that 11 randomly selected graduates all find jobs within their chosen field within a year of graduating. That's going to be real low.
11 times 0.65.
No.
Oh.
Wrong. Okay, so we have 11 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll do the first, like, you'll get the idea, okay? What's the chances that this first student got a job within the first year? 65% or 0.65. What's the chances that this one is? 0.65 and 0.65, and it's 0.65 times itself 11 times, or
To the 11.
0.65 to the 11th power, which is not the same thing as 11 times it. What? 0.00875, which as a percent is like 0.875%, so not even 1% of the time. Which is probably true, like only 65%, and now we're trying to say, what's the chances that all 11 of them are doing this? Well, that's gonna be real low, right? Okay? Does that make sense when you write it out like that? Okay? All right, 10. Determine whether the events are mutually exclusive. I'm going to say or inclusive. Okay, and that's disjoint is another way of saying exclusive. Reading a book by Mark Twain and reading about Tom Sawyer. I don't know if I have any people who know this at all in here.
I read this actually.
But
and I watched the movie.
but Tom Sawyer is in a lot of Mark Twain books. So like that is the author for Tom Sawyer. So can they be the same? Can Tom Sawyer also appear in a Mark Twain?
Yeah.
Yes. So that would be
Mutually inclusive.
inclusive, or you can just put I don't care. Okay?
Thank you guys.
Very good.
We can be nice to you.
You guys
Okay.
tell my dad that since he's proud of me.
All right. 11. Express the indicated degree of likelihood as a probability value. Your mother could not have died 2 years before you were born. If I were to represent that as a probability, your mom can't die 2 years before you're born. Like, that's just not a thing. Nowadays, we probably can't say that because, like, IVF
You can freeze them.
stuff, you can freeze them and then somebody else have the baby, whatever. And technically, your mother's dead. But anyway, so we're assuming that that's not a thing.
So.
What is the chances of your mother dying 2 years before you're born? They want us to represent it as a percentage, 0%. There's a 0% chance of your mother
like that
dying
question.
2 years before you're
Yeah,
born.
can you have a lot of these?
Yeah? Okay? 0%. What's the highest percent you can have? 100, right? No negative percents. No percentage is higher than 100, okay? All right, we've got another positive, negative, disease, and no disease. What is the probability that the subject has the disease? Has the disease given negative. So I say probability of yes given negative. That's kind of how I paraphrase it. Yes given negative.
9 out of 300.
Okay, so my bottom number is going to be what?
All the negatives.
All the negatives. All the negatives go on my bottom number. Negatives are these guys. 321, yeah?
Yep.
Okay, of those 321, how many of those were yeses? 9, okay? I have a lot of people that are trying to add the 87 and the 9 together, but we're only looking at the 321 right here.
2.8%.
Okay, 2.8%. Perfect. Okay, but when they say given, I start with the given. I start with the bottom number, given. I read this kind of backwards. Given negative. I look at all the negative people, and then I put the 9 out of those is yeses. 9 is yes. Good?
No. I what?
13. We're flying right along. Here we go. Of the 1,232 people who came into a blood bank to give blood, 397 had high blood pressure. That's a really bad deal. That's like a third of them. Yikes. Yikes. Estimate the probability that the next person who comes in to give blood will have high blood pressure.
32.2%.
How did you do that?
397 divided by
397 over 1232. This is the only thing I have to go off of. So the chances of the next person coming in is probably going to be the same as the chances that I've had previously, which is 32.1%.
Has anybody seen that yellow dummy that
For 1%?
Oh, yeah.
Two.
It's mine, Clayton.
32.2%.
Yes, I did that.
There you go. 32.2%. Okay, what is 8P for?
1680.
1680. What's P main? Permutation, which means
the order matters.
order matters. So I had 8 total, and I am choosing 4 of those, and the order in which I choose them matters, right? 8P4 is 1680. That's the number of combinations that I have of choosing just 4 out of 8 people. That's a lot of different ways I could choose 4 out of 8 people. That's like choosing first, second, third, fourth out of 8. Okay? All right, another table, but it's a bigger one. Under 21 years of age, between 21 and 40, over 40 years of age, and then we have like different drinks. So Coca-Cola, root beer, lemon lime. Why? Lemon lime. Ugh.
What's wrong with that?
Ugh.
What is wrong
It's
with
like
that?
literally
sour.
Mountain
This is
Dew.
right.
It's
Lemon
like
lime is so
sour,
good.
isn't it? Okay,
No,
whatever.
it's Sprite.
Okay,
Lemon
okay.
lime's the best Gatorade.
Maybe I shouldn't judge. All right.
Yeah.
I agree.
All right.
Oh, what?
Okay,
Lemon
if
lime is
one
Gatorade.
of, they give us the total. This is exciting. 255.
Lemon lime.
Glacier Freeze is okay.
255 is my total.
Is it the white one or the yellow one?
We don't have to add them up. That's nice. Shh. Here we go.
Oh, Glacier Cherry.
If one of the 255 is randomly selected, find the probability in fraction form that the person is over 40 and drinks cola.
Okay.
Over 40 and drinks cola. Who is that?
20.
20. This 20 right here. Over 40 and drinks cola is only 20 out of
255.
255.
Divided by 5 is what?
Sorry.
divided by 5 is 4 over 51.
That's an eight.
True? Yes?
Yes.
4 out of 51 and we leave it there. We don't convert it to a decimal.
Next.
Okay?
Oh, y'all, I was already
Yeah. Oh.
Okay, what's the chances that all 4 of them have health insurance?
0.66 to the 4th.
Yeah, so I do 4 people. 1, 2, 3, 4. What's the chances that the first one has health insurance? 0.66. Chances the second one has health insurance. 0.66. So 0.66 to the 4th power. What?
1.189. No,
No,
190.
That's just
0.190 or 19%? Perfect. If you round, it's like 0.189 something, whatever. So if you round, it's 0.190. Yep, 19% chance that all 4 of them have health insurance. That is crappy.
I have health insurance.
Oof.
Through my
Oof. Okay.
Okay.
All right. If a person is randomly, this is the last one. Is this the last one?
Yeah.
Boom. If a person is randomly selected, find the probability that his or her birthday is not
11 out
in
of
May.
My birthday's
Oh,
in May.
11 out of
no,
12.
One on three.
Okay, now hold on. We're going to talk about what Craig just said. 11 out of 12. That would be true if all of the months had the same number.
3, 4 out of
Okay, so it's not 11 out of 12. How many days does May have?
31.
31. So what did you do?
334.
Subtract it from
Subtract that from 365, so 331 or 334 out of
365.
365. Days that are not May are 334 out of 365.
91%.
9.15.
No, it's about 92%.
92% ish.
Yeah.
Perfect. Okay.
Oh my
Make
God,
sure
Korea.
make sure you catch that not in May, right? Okay? Like this is not going to be bad. Was this okay?
No.
This is not going to be bad. You're going to be
Is that how
just
the temple
fine.
test-
Yeah, but you say that, and then you make
Yeah,
the
and
test
then
as completely
like every
different.
I'm feeling good about this one, Cow Masher.
I think it's going to be fine. I think it's going to be fine. Goodbye, people on the video.